Let's take a look at systems of linear equations in three variables. In our first problem, we want to decide if the ordered pair, or not ordered pair, ordered triple gets given, is the solution of the system. So we got 3, -1, and 2. And we got 5x minus y plus z equals 18. We got 7x plus 3y minus 2z equals 14. And we got x plus y plus z equals 4. Now, they give us this order triple, so that's x, y, and z. So we'll just plug in the x, y, and z into the appropriate places. So 3 for the x minus -1 plus 2. And this is more of a question mark. We're wondering if that's equal to 18. 5 times 3 is 15. Negative becomes positive. Plus 2. 15 plus 1 is 16. Plus 2 is 18. So we get 18 is equal to 18. So that one checks. Now we're going to plug it in here. So we got 7 times 3 plus 3 times -1 minus 2 times 2. Again, plug in our x, y, and z. And we're wondering if this is true. So we've got 21. 7 times 3. 3 times -1 is -3. -2 times 2 is -4. I wonder if that's equal to 14. 21 minus 3 is 18. Minus 4 is 14. So we get 14 is equal to 14. When these match, that means it checks. And we'll plug in our last one. So put 3 in for the x, -1 in for the y, and 2 in for the z. And this is a question mark at this point. 3 minus 1 is 2, plus 2 is 4. So we get 4 equals 4. Since all three, the answer is yes on, then the answer is yes. This is a solution for this system of equations. Well, let me start a new page. These are kind of long problems. Let's take a look at this problem. 2x plus 3y minus z equals 8. 5x minus y plus 2z is equal to 17. X plus 7y plus z is equal to 28. And this is our first equation, this is our second equation, this is our third equation. It says solve each system. So step 1. I'm going to group equations 1 and 2 together. And eliminate the z's. So I have equation 1, which is 2x plus 3y minus z is equal to 8. And 5x minus y plus 2z is equal to 17. And we want to eliminate the z's. Well, this is a positive 2z here. We would need this to be a negative 2z. So we're going to multiply everything in the first equation by 2. 2 times 2x gives us 4x. 2 times 3y gives us 6y. 2 times negative z is negative 2z. And 2 times 8 is 16. Second equation remains as is. Now I'm going to add these together. This is referred to as the addition method, elimination method, depending upon the book you're looking at. 4x plus 5x is 9x. 6y minus y gives us 5y. Negative 2z plus 2z cancels away. And 16 plus 17 gives us 33. This is equation 4. Okay, step 2. Group equations 2 and 3 together. And eliminate the z's. Okay, so our second equation is 5x minus y plus 2z equals 17. And then x plus 7y plus z is equal to 28. Now, this is a positive 2z. If this one was a negative 2z, then I'd be able to add these together and eliminate the z's. So I'll multiply the second equation by negative 2. First equation remains as is. Negative 2 times x is negative 2x. Negative 2 times 7y is negative 14y. Negative 2 times z is negative 2z. And negative 2 times 28 gives us negative 56. And I want to add these together. 5x minus 2x gives us 3x. Negative y, negative 14y is negative 15y. 2z minus 2z drops away. 17 minus 56. 39. Negative 39, I believe. And this is our fifth equation. Now I could actually divide everything by 3 in that one, but and as in this case it would work out very well, but we'll ignore that. I like steps to work all the time. So step 3. Group equations 4 and 5 together. And eliminate the y's. Okay, so equation 4 was up here. It's 9x plus 5y equals 33. And this one is 3x minus 15y equals negative 39. Now we're used to multiplying everything in an equation by a number, and I'll stick with that since that's what we've done over and over. Now this is negative 15y. If I multiply the first equation by 3, that'll become a positive 15y, and those will cancel away. So 3 times 9x gives us 27x. 3 times 5y is 15y. 3 times 33 is 99. And we got 3x minus 15y equals negative 39. That gives us 30x. 15y minus 15y drops away. 99 minus 39 gives us 60. And that's the equation 6. Well, step 4. Solve equation 6. We got 30x is equal to 60. Divide both sides by 30. And we're going to get 60 divided by 30 gives us 2. Now, back here, we had equation 4 and 5. Now we're going to plug it into either 4 or 5. It doesn't matter which one you want to plug it into, and solve for y. So step 5. Plug this value into equation equation 4 or 5 and solve. Okay. I might as well do, well, actually the other one's a little bit easier, looks like. 9x plus 5y equals 33. Okay, we just said x was 2. So we got 9 times 2 plus 5y equals 33, which gives us 18 plus 5y equals 33. Take the 18 to the right side. We got 33 minus 18, which gives us 15. Divide both sides by 5, and we get y is equal to 3. Now, so far, this is our first part of our answer, and this is the second part of our answer. So now we know x and y. So if I come back up to here, you can plug it into any of the first 3 equations and solve for z. So, step 6. Plug the x, y into equation 1, 2, or 3 and solve for z. What was our first equation? 2x, or yeah, that's pretty easy. It's 2x plus 3y minus z is equal to 8. Okay, now we know x. X is 2. We know y. Y is 3. Minus z equals 8. So we got 2 times 2 is 4. Plus 3 times 3 is 9. Minus z equals 8. 4 plus 9 is 13. Minus z equals 8. I'm going to take the negative z over to the right side. Take the 8 over to the left side. So we've got 13 minus 8 equals z, or z is equal to 5, which is the third part of our answer. So our answer is 2, 3, 5. Well, let's show this problem again using the calculator. Not that easy to do by hand, you see. So we got 2x plus 3y minus z equals 8. 5x minus y plus 2z equals 17. X plus 7y plus z is equal to 28. Okay. Solving a system of equations, specifically linear, but using T83, 84. Now, you saw these steps back when we had 2 equations, 2 variables, and they're the same ones. First step is get all the terms with a variable in them. On the left side, numbers on the right side. So we want to get our constant terms on the right side by themselves. Step 2, write down your matrix. Step 3, input your matrix. And be sure you do a second mode to exit out after you get done inputting it. Step 4, we're going to our matrix menu. Actually, let me just write that out that way. So go into the matrix menu, and we're going to right arrow, to math, and up arrow to RREF. Then we'll do enter. Then we'll go into our matrix menu again. Enter on A. And enter again. And then if there's decimals, then you do math, enter, enter. So math, enter, enter. Well, let's look at this one. Get all the terms, the variable on the left side, numbers on the right side. Well, everything with the variables on the left side, numbers on the right side. So that's done. Write down your matrix. To write down our matrix, we drop our x's, our y's, our z's, and our equals, and just keep the numbers in their signs. So we're going to have 2, 3, negative 1, 8. We'll have 5, negative 1, 2, 17. 1, 7, 1, 28. Let me double check my numbers. Looks good. Now this is our size of our matrix is rows by columns. This is 3 by 4. So step 3 says input your matrix. Well, let's go take a look at that. So we'll bring my calculator up. Okay, so to get on my matrix menu, see above the x and negative 1 button? That's your inverse button, actually. Above the x and negative 1, it says matrix. So we'll do second x and negative 1 to go into it. Now, those of you with just a T83, not a T83 plus, but a T83, you actually have a button that says matrix. To input our matrix, we're going to right arrow over to edit. And A is already highlighted, so we do enter on it. Now, come up and ask us for the size of our matrix. We said this one was a 3 by 4. So you do 3 enter, 4 enter. It's hard to screw that up because your matrix won't look like what you're trying to enter if you put in a 4 by 3. Now notice there's 3 little dashes over here at the right hand side. That means there's more of the matrix you can't see on the screen. It'll automatically scroll over. You don't need to worry about that. And we just start putting our numbers in, pressing enter after each one. So I'll do 2 enter, 3 enter, negative 1 enter, 8 enter, 5 enter, negative 1 enter, 2 enter, 17 enter, 1 enter, 7 enter, 1 enter, and 28 enter. And then we want to exit out after that. So we'll do second mode to exit out. Again, you have to make sure you do a second mode. Now this tells us to go back in the matrix menu. So we're going to do second x and negative 1. It says right arrow to math. So I'm going to right arrow to the math. And it says up arrow to RREF. So I'm going to up arrow to RREF. Then it says do enter. Then it says go into your matrix menu. So we'll go back into it. Second x and negative 1. It says do enter on A. I'm under the names menu. See how A is already highlighted? So we just press enter. And then it says enter again. Now we had 3 equations, 3 variables. So our first 3 by 3 matrix should be a diagonal of 1, 0, everywhere else. And it is. And our far right column is our answers. So I got 2, 3, 5. So our answer for this would be 2, 3, 5, which is the same thing we found on the last problem. Well, since we're right here and we're ready to do the next problem, let's go ahead and do it in the matrix or in the calculator first, and then I'll do it by hand. So I got 2x plus z is equal to 13. X plus 3y minus z is equal to 14. 3x minus 7y plus z is equal to 14. Okay, now first step is get everything with a variable on the left side, numbers on the right, and that is. We want to write down our matrix. Now when we do that, we're going to have basically an x column, we'll have a y column, we'll have a z column, and then the other side of the equals. So I'm going to have 2. Now notice my first equation, I'm missing the y, aren't I? You have to put a 0 there for it. And then 1 for the z, and then our other side is 13. And then this will be 1, 3, negative 1, 14. 3, negative 7, 1, and positive 14. Now it's still a 3 by 4, so let's go ahead and put that in. Okay, so I'll do second, x and negative 1, go to matrix menu. Want to right arrow over to edit, do enter on A. It's 3 by 4, so I do 3 enter, 4 enter. And we got 2 enter, 0 enter, 1 enter. 13 enter, 1 enter, 3 enter, negative 1 enter, and 14 enter. Last row. 3 enter, negative 7 enter, 1 enter, and 14 enter. Okay, so after we get that input, we want to make sure we exit out, so we do second mode. Now go back to my matrix menu, so I do second, x and negative 1, right arrow to math, up arrow to RREF. Again, make sure you choose the one with 2 R's. The one with 1 R will give you wrong answers. The RREF we'll see later on when we talk about matrices, but it stands for reduced row echelon form. So do enter on it, go back in my matrix menu, do enter on A, enter again. And our answer is, well, assuming we got diagonal 1s and 0s everywhere else in our first 3 by 3 square, our answer is the right-hand side column. So our answer to this one would be 8, 1, and negative 3. Okay, I'm lying. While we're at it, let's go ahead and just put 4 into our calculator, and then we'll go back and do them both by hand. Okay, so I got 4z minus 27 equals 5 times x minus 2y. And then we got 2y minus z minus 4 equals negative 3x. And we got negative 16 plus 6z equals 2 times negative x plus y. And let me double check everything real quick. Okay. Well, I got parentheses, so I need to get rid of those parentheses first. So I got 4z minus 27. 5 times x is 5x. 5 times negative 2y is negative 10y. Now, don't have any parentheses on the second line, so I want to get all the variables on one side and numbers on the other. So I take negative 3x to the left side. It becomes positive 3x plus 2y minus z. And I'll take the negative 4 to the right side, and it becomes a positive 4. Now our last one has parentheses, so let's get rid of those parentheses first. So I got negative 16 plus 6z equals 2 times negative x is negative 2x, 2 times y is 2y. Still want to get everything with a variable on left side, numbers on the right. So I'll take the 5x minus 10y to the left side. So we got negative 5x plus 10y plus 4z, and I'll take negative 27 to the right side, and it becomes a positive 27. Second one is fine. We got 3x plus 2y minus z is equal to 4. On my last one, I'm going to take the negative 2x plus 2y to the left side. It becomes a positive 2x minus 2y. And we already have a 6z over there. And I'll take negative 16 to the right side, and it becomes a positive 16. Now, assuming I didn't mess up on a sign somewhere, we're not ready to write down our matrix. Again, the x's are in the same column, the y's are in the same column, the z's are in the same column. That's what we want. So we've got negative 5, 10, 4, 27. 3, 2, negative 1, 4, 2, negative 2, 6, and 16. So let's go ahead and put this in. Second, x and negative 1. Right arrow over to edit. Enter on A. It's a 3 by 4, so do 3 enter, 4 enter. Negative 5, enter. 10, enter. 4, enter. 27, enter. 3, enter. 2, enter. Negative 1, enter. 4, enter. 2, enter. Negative 2, enter. 6, enter. And 16, enter. So let's exit out, do a second mode. Now we're going to go and do our REF. So do second, x and negative 1. Right arrow to math. Up arrow to REF. Enter. Go back in the matrix menu. Do enter on A. And enter again. And that implies I entered something incorrectly. So let me go back and look, see what I did wrong. Second, x and negative 1. Go over to edit. 3 by 3. 3 by 4. I wasn't even looking as I was entering the numbers. 5, negative 10. 4, 27. 3, 2, negative 1. 4, 2. This, by the way, what I just did there is the most common thing to do on these. Is just enter it in incorrectly. Let me double check myself now. Since I screwed up the first time, I would redo it, this video, but I'd probably screw up again in inputting the numbers. It's so easy to mess up on a sign. If you're taking one of my tests and using the calculator, be sure you write down the buttons you use on it. That's the only work I have to look at. And as you can see, it's so easy to input something wrong. Okay, let's go do it again. Second, x and negative 1. Right arrow to math. Up arrow to REF. Enter on it. Go back to the matrix menu. Do enter on A and enter again. And I have the answers over here on the side, so that is correct. Our answer is 1, 2, 3. Now, if you're wondering, the order of the answers, this is X, this is Y, and this is Z. But why? That's because that's the order we put them in here. X was first, Y was second, Z is third. So this will be X, Y, and Z. If I had put the Z's first, and then the X and the Y, then we would have had Z here, X, and then Y. Well, let's go back now and look at these by hand. So we're going to go back to number 3. This is actually usually where I screw up. I'll add something wrong or multiply something wrong. But I'm being really careful today, which probably means now that I've said that, I'll screw it up. X plus 3y minus z equals 14. 3x minus 7y plus z is equal to 14. Okay, let's label these. First equation, second equation, third equation. Okay, now step 1. Step 1 was to group the first two equations together, equation 1 and 2. So we've got 2x plus z is equal to 13. And we got x plus 3y minus z is equal to 14. And we want to eliminate the z's. Well, this is perfect because I have a positive z and negative z, so they're going to go ahead and cancel away. 2x plus x is 3x plus 3y. Z minus z drops away, and 13 plus 14 gives us 27. Now, I'm going to go ahead and see how these are all divisible by 3. I'll go ahead and divide all of them by 3. So we got x plus y is equal to 9. I didn't do that in an earlier problem, and I was kind of debating whether I should, but Sometimes it's beneficial, sometimes it's not. Step 2, group equations 2 and 3 together. So I got x plus 3y minus z is equal to 14, and 3x minus 7y plus z is equal to positive 14. Well, x plus 3x is 4x. 3y minus 7y is negative 4y. Negative z plus z drops away. 14 plus 14 is 28. Now let me double check everything. It's like I say, I do screw these up real easy. I add numbers wrong. I think that's alright. Okay, now notice these are all divisible by 4. So I'll go ahead and divide them by 4. So that gives me x minus y equals 7. And this is equation 5. Step 3. Group equations 4 and 5 together and eliminate the y's. So we've got x plus y equals 9. And x minus y is equal to 7. X plus x is 2x. Y minus y drops away. 9 plus 7 is 16. And this is equation 6. Step 4 was to solve equation 6. So we got 2x equals 16. Divide both sides by 2. And we get x is equal to 8. Step 5. Step 5 was to plug this x value that we just found into either equation, see how both equation 4 and 5 have x's and y's? Plug it into either one and solve for y. I'll pick the first one, the equation 4. So we got x plus y is equal to 9. And back here in step 4, we found our first part of our answer. X is equal to 8. So we'll put 8 in for x. So we got 8 plus y equals 9. Take the 8 over, we got 9 minus 8, or y is equal to 1. Step 6. We want to plug the x and y we just found back into one of our first 3 equations, and then solve for z. That doesn't matter which one you pick. First one's actually the easiest. So we got 2x plus z is equal to 13. We just said x was 8. So I'll put 8 in for x. Now y we don't even have in here, so it makes it even a little bit easier. So that gives us 16 plus z is equal to 13. Take the 16 over the left or right side. Becomes a negative 16. Which gives us negative 3. That's the third part of our answer. So our answer is 8, 1, and negative 3. Now I'm going to start a new page and work our last problem. Okay, so let's look at this one. We've got 4z minus 27 equals 5 times x minus 2y. 2y minus z minus 4 equals negative 3x. Negative 16 plus 6z equals 2 times negative x plus y. Double checking everything here. Okay. Well, first thing is we need to get rid of all the parentheses, get everything with a variable on one side and numbers on the right side. So let's see, I got 4z minus 27 equals 5 times x is 5x, 5 times negative 2y is negative 10y. And actually, let me go ahead and rearrange that second equation. We'll take the negative 3x to the left side and negative 4 to the right side. So we'll get 3x plus 2y minus z is equal to positive 4. And I need to get rid of the parentheses on the third equation. 2 times negative x is negative 2x. 2 times y is 2y. Now back to our first equation. I'm going to take the 5x minus 2y, or 5x minus 10y, take them to the left side, take negative 27 to the right. Take these to the left, take that to the right. So I got negative 5x plus 10y. I'm not sure if I've woken up yet. It's kind of sad since it's noon. Plus 4z is equal to 27. 5x plus 10y plus 4z equals 27. Okay. This one is fine. 3x plus 2y minus z is equal to 4. And on this one, I'll take these over the left side, take the negative 16 to the right side. So I get 2x minus 2y plus 6z is equal to 16. Now I'm going to double check myself and everything here. You start out with a sign wrong and that screws it all up. There's nowhere to go but down. Okay, I think I got everything right there. So this is my first equation, this is my second equation, and this is my third equation. So step 1. Group the first two equations together and eliminate the z's. So I got negative 5x plus 10y plus 4z is equal to 27. We got 3x plus 2y minus z is equal to 4. And this is 4z. If this was a negative 4z, then we could eliminate those. So I'm going to multiply the second equation by 4. So first equation remains as is. We got negative 5x plus 10y plus 4z is equal to 27. 4 times 3x is 12x. 4 times 2y is 8y. And 4 times negative z gives us negative 4z. And 4 times 4 is 16. Okay. I add these together. Negative 5x plus 12x is 7x. 10y plus 8y is 18y. 4z minus 4z drops away. 27 plus 16 gives us 43. And that's our fourth equation. 7, 18, 43. Okay. Step 2. Group the equations 2 and 3 together and eliminate the z's. So I got 3x plus 2y minus z is equal to 4. And 2x minus 2y plus 6z is equal to 16. Looks like I could actually divide everything in the second equation by 2, but I'm not going to worry about that. Here I have 6z. If this was a negative 6z, when we could add them together. So I'll multiply the first equation by 6. So that gives us 18x plus 12y minus 6z equals 24. 6 times 3x is 18x, 6 times 2y is 12y, 6 times negative z is negative 6z, and 6 times 4 is 24. 2x minus 2y plus 6z is equal to 16. Well, 18x plus 2x is 20x. 12y minus 10y, or minus 2y is 10y. Negative 6z plus 6z drops away. 24 plus 16 gives us 40. And it looks like I can divide everything there by 10. So that'd give us 2x plus y equals 4. And that's equation 5. Now I'm going to double check myself here. By 6. 18, 12, minus 6, 24. I add them together. 2x minus 2y plus, I wrote it down correctly. 20x plus 10y equals 40. Divide everything by 10. Okay, that looks okay. Well, step 3. Group equations 4 and 5 together. So we got 7x plus 18y equals 43, and 2x plus y equals 4. And eliminate the y's. So if this was a negative 18y, so I'm going to multiply everything in this second equation by negative 18. So we've got 7x plus 18y equals 43. Negative 18 times 2 gives us negative 36x minus 18y equals negative 72. That gives us negative 29x. 18y minus 18y drops away. This gives us negative 29. That's promising. That's equation 6. Okay, let me scoot down here. There we go. Step 4. We want to solve equation 6. So we've got negative 29x equals negative 29. We'll divide both sides by negative 29. And we get x is equal to 1. And that's the first part of our answer. Well, step 5. We want to plug that value into either equation 4, see how it says x's and y's, or equation 5. This has x's and y's. Now equation 5 looks a little easier, actually. So let's plug it in. 2x plus y is equal to 4. Now we'll put 1 in for x. So we've got 2 times 1 plus y equals 4. So we've got 2 plus y is equal to 4. Take 2 over, and we've got y is equal to 4 minus 2, or y is equal to 2. Step 6. Now plug this x and y into one of your first 3 equations. And the second one maybe looks a little easier. Doesn't matter. All of them will give you the same answer. So I got 3x plus 2y minus z is equal to 4. And we just said that x was 1, y is 2, minus z is equal to 4. So we got 3 plus 4 minus z is equal to 4. 7 minus z is equal to 4. Take negative z to the right side, take the 4 to the left side. Anytime you take a number across your equals, your sign changes. So we got 7 minus 4 is equal to z. Or we get z is equal to 3. So our answer is 1, 2, 3. Now some things to note here. I've tried to give you a step-by-step that works on all problems. Of course, the minute I say that, there'll be some oddball ones that don't work on, but they'll work on probably 95, 90, 97% of the problems. Sometimes, instead of working to eliminate the z's to begin with, you can pick a different variable. So like in step 1 and step 2, where we eliminated the z's, if you want to eliminate the y's, that's fine. Then in step 3, you can pick a different variable to eliminate. So, you know, it's kind of depending upon what the problem looks like. Like, look here at our original equations. We had 2y minus 2y. Those would eliminate so nice. But again, I like step-by-step works on 100% of the time, or as close as I can get to that. So let me stop the recorder and save this.